5. This is good. This is good. All right, so today's do now, I want to do 2 different ways. Why not? Why just do a problem once when you can do it twice, right? Okay, so we want to get this limit, and the 2 basic ways to do it are the way, well, the first way, where is it here? Oh, here we are. The first way is by using the definition of the derivative. Remember the definition of the derivative, f prime of x equals the limit, as h approaches 0, all that. So whenever you're asked to find the limit of that form, okay, realize that this whole limit is equal to the derivative of the function following the minus sign, evaluated at that number, if they put a number in. So let's go through this one way, and then we'll try it another way. So if we were to try to match up our problem to the limit definition of the derivative, what's the function going to be in terms of x, though? Sine of x, right? You don't plug in the number until after. Then you say, okay, well, that whole limit is equal to the derivative of that function. So what's the derivative of sine x? And then if they have plugged a number into that function, as they have here, you plug that number into your derivative after you find the derivative, right? So cosine of pi over 3. Now let's not touch your calculators. Let's try to remember. First of all, pi over 3 radians, 60 degrees. Now I know there's probably 3 numbers floating around in your... 1/2. That was right. Is anyone thinking like rad 3 over 2? Or... Oh, you got that? You guys are okay with that? I was expecting a big problem. Oh, well, I don't know what I'm going to do for the rest of this period. No, that's great. So it's a half. So that is the answer. Okay. Well, sometimes there is another way to do these if you ever want to like check it in another way, and it's called L'Hopital's rule. And this is not in the curriculum for Calc AB. I think I mentioned it once before, but I just want to mention it again because it really can get you out of a jam with limits. Let's say you have a limit that's in an indeterminate form of 0 over 0 or infinity over infinity. That's the case where you're allowed to use this. Now, which one of those indeterminate forms do we have here? If you plug in 0 for the h's, do you get infinity over infinity or 0 over 0? 0 over 0. And no one knows what that is, right? That's an indeterminate form. And as long as you get one of those 2, what you're allowed to do with L'Hopital's rule is replace the numerator with its derivative, replace the denominator with its derivative, and then try to find the limit again. In other words, plug in the 0 into any h's. Now, when you take the derivative of the numerator and the denominator, just realize that if h is approaching 0, h is the variable. Okay, so h is like your x when you're taking the derivative. So let's try it. Let's start with the derivative of the denominator since that's a little easier. What's the derivative of h if h is the variable? 1. Now let's take the derivative of the numerator. What's the derivative of the first term? Cosine of pi over 3 plus h. Remember, the angle never changes. Then we always do times the derivative of the inside. The derivative of the inside is 1. So you don't have to write times 1. You can. It's not wrong. Okay, so we took the derivative of the sine of pi over 3 plus h. Minus, we got to take the derivative of sine of pi over 3. Okay, so you got to take the sine. Wait, the sine. It's not. Okay, time. What did you just say at the end? Times 0, because the derivative of the inside is 0. So what is the derivative of a value, a number here? Just 0. Okay, that's just a number, the sine of pi over 3. It doesn't matter if you don't know what it is. It's just 0. Or using the chain rule, like Cameron did, you still get 0. Okay, so what we did, we just replaced the numerator with its derivative. We replaced the denominator with its derivative. Now we try to get the limit again by plugging the 0 in for h. If we plug 0 in for h, what do we get? We get the cosine of pi over 3 plus 0, right? I'm not writing the rest of it. And what does that equal? Cosine of pi over 3, which equals 1/2. So L'Hopital's rule is good not just for limits that could also work with the limit definition of the derivative, but anytime you get one of those two indeterminate forms. Sometimes you have to keep going and going until you don't get 0 over 0 anymore, but it's nice. I just thought I would throw in one tougher problem on that just to see if you could handle a little twist. You think you can? I don't know. If you flip is this from the back of yours? I think it's on the back. Okay, so here's another one. Here they don't ask you for the limit. They actually tell you that the limit as h approaches 0 is 2. And you got to find the value of a. You don't know what the derivative of arcsine is? One minus x squared in the denominator. So the function is arcsine. You're used to seeing it written like this, right? So the function, oh, I didn't leave room, but that's okay because I can do that. So the function that we're talking about, so this is the limit definition of the derivative. So we first identify the function. Then after we identify the function, which follows the negative sign, then what do we do? We're using take the derivative, and this is why we were all stuck. But then we remembered it's 1 over the square root of 1 minus x squared. Now, they plugged something in for that, didn't they? What did they plug in for the x? A, right? So f prime of a is equal to 1 over the square root of 1 minus a squared. That's what this whole limit equals, but that's not what they're asking us for. They're telling you that this whole limit that we just found, the derivative of a, equals 2, and they want us to solve for a. What do we do? Set it equal to 2. I like that. 1 over the square root of 1 minus a squared equals 2. Now we got to solve that for a, and it says it could be. Actually, there are two values that would work. Cross multiply and divide, or just flip both sides. I'm just going to flip both sides, or cross multiply and divide. Yeah, I like that. So that way we'd have the square root of 1 minus a squared equals 1/2. Then what would you do? Square both sides. I like the way you're thinking. So 1 minus a squared equals 1/4. Okay. So you really want to have negatives on both sides? I don't like to be negative. Yeah, you're right. You're right. All right. I'll do it. All right. I was going to bring that. All right. Negative a squared equals, it's 1/4 minus 1. 1/4 minus 4/4. Negative 3/4. Negatives cancel. Multiply each side by -1. So they're gone. So now we have square root. So, no, technically we could take plus or minus the square root of 3/4. Yeah, it is. When you take the square root of a fraction, yes. So you would get, so a could be either plus or minus the square root of 3. Square root of 4 is just 2. Now, that's why in the question they said a could be, and then they have the positive square root of 3 over 2. Because it could also be the negative, but that's not there. What did you think about that one? It was a little fun, right? A little twist. That's what I'm talking about. This is where the enjoyment comes in. All right, so let's talk about some of these sample homework questions. Yeah. Oh, that just means that there are materials available if I want to learn how to teach that. but the other ones just mean you needed a graphing calculator. With the answer key that I gave you, she was asking what does this symbol mean. That's just for teachers to know about. But this, the only ones you needed a graphing calculator for were number 15, 23, 24, 19. All right. That's the, goes with your homework. Dive in. Well, you're going to tell me what number to dive into. 7? So, Ashley, it wasn't that you left your homework at home. You didn't do it? You said, oh, I've never seen these. Wait, well, oh. Well, we'll go jumping around. Did I hear number 6? Did someone say that? Okay. So 6, you have to get the derivative at 0. Before you can get the derivative at any number, first you got to get the rule for the derivative. Did you rewrite it? You did? Oh, no. All right, let's find out what you did wrong. So you took the derivative, and it's 2 times the sine of, I'm just guessing what's in there. What is it, 3 minus? Okay. To the first, right? So that's the squaring done. We move that squaring. Then the derivative of the sine of an angle is cosine. So this is going to be times cosine of the angle. Oh, did you forget the derivative of the innermost angle? The layer, I mean? Yeah. So times to the inside is -1. Ouch. Then you have to just plug in 0. Do you see where we got that from, though? Jess, you would ask me this one? Oh. Okay. So now, should I follow this one through, or are we good? This one's done. Did anyone else want to see the rest of this one? Plug in 0. All right. What do you want to see next? Did I hear 7? 7. Solution to the differential equation. Now, you see how that derivative has x's and y's in it? That means you're going to have to separate. You got it right? Nice. You separated into it. Let's see if you separated right. Because everyone thinks it's an ln all the time when it's not. When you separate these, y dy equals 4x dx, and you integrate. If you didn't get this one right, check if you separated right, because everyone thinks everything's going to be an ln. Oh, y of 2 is -2. Oh, this is when we get the y squared. Yeah, so you take the integer this side, you have the 1/2 y squared. We save the plus c for the other side. What you get for the antiderivative of 4x? Okay. Let's multiply each side by 2. Just get rid of this half. Remember, our goal is to solve for y. But let's just have y squared equals 4x squared plus c. Some other kid named c. Right. Now, yeah, I like to get the c before I take the square root. Before it gets too crazy. We'll get c now. So y of 2 equals -2. So -2 squared equals 4 times 2 squared plus c. 4 equals 16 plus c. So what does c equal? C equals -12. You go back to the step right before you plugged in the number. So that's right here. And you plug that in. So right now we know y squared equals 4x squared minus 12. Now we gotta get a function out of this. And so normally you solve for y, you would say plus or minus the square root. But you actually just can't leave it. It's one or the other. You got to decide. And the way you decide is it has to go through that given point. Remember the point that they gave us when x is 2, y equals -2? You only have to worry about this when your solution is y squared equals. That you have to know whether it's the positive square root or the negative square root. So yeah, you have to choose the negative square root so it'll go through that point. So y equals the negative square root. If it went through 2. Yep. If y of 2 is positive 5, you take the positive square root. The thing with solutions to differential equations, they can't cross any value that makes the denominator of the differential equation 0. So my solution can't cross the line y equals 0. So it's either above it or below it. And that's, with a given point, that's how you decide which side you're picking. 5. Anyone else want 5? Aww. Okay. When you look at a function and then they ask you about the, I'm glad you asked this one. How many extrema? That's when the first derivative changes sign. Relative extrema, that's when the first derivative changes sign. Points of inflection, that's when second derivative changes sign. It actually has to change sign. So you look for the extrema first. You take the derivative. And what do you get here? 4x cubed minus 6x squared. Now, you want to know where it could change sign. Anything can only change sign at a critical value, where it's either 0 or undefined. There's no way you can jump from a positive to a negative unless it's either undefined there or it's 0. So to get the critical values, you say, all right, is it ever undefined? Nope. Is it 0? Yeah, we'll find out. We'll set it equal to 0. We'll factor to solve that, right? To find out where something equals 0, we could 2x squared. And we have a 2x minus 3. And we can find those values and make it 0. Well, product equals 0 when any of the factors is 0. So what are your critical values? What are the only values where the first derivative could change sign? 0 and 3 over 2. Now, I'm not just going to go into this blind because, you know, do you guys remember, I know it's been a while, but when you have a factor that's raised to an even exponent like the x's, yes, bounce the graph. So is it going to change sign? No. Expect no sign change at 0 because the factor x is to an even power. Right? You want to think about this before you do it, because if you just plug in a number and you just make a silly mistake, you know. So really, how many sign change should I expect from this? Just 1. Which means there's only going to be 1 relative extrema. You would use, when you're plugging in values, you plug into the factored form. And 2x squared is always positive. 2 is always positive, x squared is always positive. So you just got to see if this factor is positive or negative. Say you take a negative number, 2 times negative 50, negative 100 minus 3, that's negative, right? Like 1. Okay, again, that's always positive. 2 times 1 minus 3, that's negative. Oh, we were right. No sign change at 0. We're psychic. Then you take a number greater than 3 halves. 2, I like that. Again, we only care about this factor because everything else is positive. And that's 2 times 2 minus 3 is positive. Okay, so we have 1 sign change, which means we have exactly 1 relative extreme. Now, I think with the choices, there was only one choice that had a... Was there only just one choice that had just 1? Wait, this is 1. Oh, so the only choice it could be is this one, right? That's the only one that has 1 relative extreme. And what kind is it? Max or min? Min, right? Negative to positive. If there was another choice, okay, that said 1 relative extreme, then I'd have to go to the second derivative to do the exact same thing to get your points of inflection. You first get the second derivative, 12x squared minus 12x. The only places this could ever change sign is where it's either undefined, which is nowhere, there's no denominator to be 0, or when it's 0. So find out where it's 0. And you factor out of 12x, right? So what are my critical values? What values of x, where could it change? 0. So you make a little sign chart for your second derivative, only marking it off at 0 and 1. Now, do we expect sign changes at each of these? Yes, because look at the exponents on each of the factors. It's 1. So you expect there to be a sign change. So right away, before I even plug in numbers, I know there are going to be 2 sign changes. But you know, if you're interested, you could just take a value over here. Everybody's positive. Value in here. This is positive. That's negative. And here. Well, if you know, you have to test to see where it starts. If it's positive or negative, you're gonna have to take a value, plug it in. As long as you didn't make a mistake with the first one, yeah. But what if you did? That's why. Sometimes. All right, so that was fun. What's the next one we want to go over? Yes, Manny. 3. Slope of the tangent. What are they talking about? Oh, derivative. Okay, so we got to get the derivative, dy dx, at the point 2, 1. So did you go through the whole thing and then you got the wrong answer? This is painful when this happens because there's always an implicit differentiation. You know, where did I make a mistake? All right, first of all, I hope you used 2 product rules if you did this one. Right. So for the first term, you got first times derivative of the second plus second. What's the derivative of y cubed with respect to x? Oh, you guys are so good. Okay, so I had 1 product rule so far for the first term. Then we move on to the second term. Okay, first y squared, derivative of the second, 2x, plus the second, oh no, x squared times derivative of the first, 2y. Ah, I got dy dx. All right, do I have it all in there? And then we have to take the derivative of 6, right? The other side. You can't just take the derivative of one side. That's 0. Just made it. Now, when you after you take the derivative of both sides, remember the general idea with implicit? But before you pull the dy dx out, you're saying, you could substitute now. That actually is true. With numbers, you could. I didn't even think of that. What? Usually you get all your dy dx terms on the left, you subtract and move the other ones over, and then you factor out dy dx. Do you guys want to substitute now? Do you think that's easier? I mean, Well, which way did you do it? Did you keep right now? You're brave. All right, I'm going to try your way. Okay, so normally you would just subtract any term that didn't have the dy dx in it. You'd move it to the other side. Then you could factor out dy dx, etc. Yeah. All right, but we're going to play it this other way. So 2 for x, 1 for y. So 1 cubed is 1 plus 2 times 3 times 1 squared, that's 1. Dy dx plus 1 squared, that's just 1. 2 times 2 is 4. Plus 4 times 2 times 1 dy dx. 0. At least the numbers aren't so bad. Let's see. So we have 1 plus 6 dy dx plus 4 plus 8 dy dx equals 0. So let's see. Let's combine like terms. So as far as the dy dx is, looks like we have 14 of them, right? We have 6 and plus 8 of them. So we have 14 dy dx, and then we have the 1 plus the 4. So plus 5 equals 0. And then you could subtract 5, divide by 14, and you got it. I kind of like that way. Maybe that's easier doing it. When you have to evaluate it at a particular point, maybe just plug it in. All right, so dy dx equals negative 5/14. Nice. What else? What else? Yes. 13? Uh, this is a good one. You guys like this one? I looked at it and I just didn't do it because I didn't like the way it looked. Is anyone going to say that? Usually somebody says something like that. I didn't like the way this one looked, so I didn't do it. I didn't try. All right, so let's see. They give you this weird function, and then they ask you about its derivative, and then the value of y. So let's do the derivative part. Let's see what its derivative is. Right? So if y equals all that, the derivative, you know what, guys? You take a break. I'll take the derivative of the 5. You relax for a second. Okay, so I got the derivative of the 5. All right. Now you got to come back to me. How do you take the derivative of a definite integral? Remember that thing, that second FTC? Yeah. Derivative of the upper, then you plug in the upper, and then you subtract. But when you take the derivative of the lower, what's that part going to be? 0. So we forget about that. So it's derivative of upper, which the derivative of the upper limit of integration is just 2. Now, do you plug in the derivative of the upper or the upper? The actual upper. Squared. Okay, because then it would be minus 0, so we don't need that. So 2 is from the derivative of upper. Then you plug in the upper limit, the 2x, into the t. So let's just see what we get for this. So we'll square the 2x. So that's 4x squared. And then you multiply by negative 1. So we have 2e to the negative 4x squared. But then we look. We got a few choices, huh? For the first derivative. Because we don't know if it's this one or this one. Okay, but we've narrowed it down. Now, there is one value of x that I could plug into that weird looking function and I would know it. And you would too. What value of x, if you plug it in, will you know the value of this definite integral? Riley? 1, right? If you plug in, if you take the definite integral from 2 to 2 times 1, what is that part going to be? 0. So when you go to find y when x is 1, it's just 5 plus the definite integral from 2 to 2. Don't even tell me what follows. I don't care. That's going to be 0. Right? I don't even care. Isabel? Wait. Oh, from this over here? When you take the derivative of a definite integral of some other function in t, it's derivative of the upper limit of integration. See, if it was just an x, that would just be 1. But if it's anything else, it's derivative of, that's the 2. Then you multiply that by what you get when you plug in the upper limit in for the t. And then you do the same with the lower, with the subtraction. Somebody else asking me a question about that or something? All right, what's the next one you want to see, kids? Oh, I like it when you agree. Yes! I was hoping you'd ask this one. You did? Did you get it all without a calculator? Nice. Okay, well, the thing is, you need the area. So the only question I have for you, do you want to use horizontal or vertical strips? Vertical, duh. Right? The answer is vertical, duh. Okay, so area, if you're using vertical strips, is the sum of the height, which is y top minus y bottom, times the thickness dx. Oh, we need to know smallest x to greatest x. We need to. So 0 to something. Yeah, if you want to find out where two functions intersect, in particular you want to know the x coordinates where they intersect, set their y's equal to each other. So y on one of them is 5x minus x squared. Y on the other graph is 2x. Now, it's quadratic. Let's get it equal to 0. Everybody's got to go to the right. Nobody's allowed left here on the left. So we'll have 0 here. We could add an x squared, subtract a 5x, and then we could factor, right? To solve any equation equal to 0, if you can factor, that's the way to go. So we find out they intersect when x is 0 and when x equals 3. Those are our limits of integration. Now, y top is the y on the parabola, which equals 5x minus x squared. So we're integrating from 0 to 3. 5x minus x squared minus y bottom. That's the y on the line, 2x. Nice. So before you integrate, it's better, if you can clean it up a little. So the 5x minus 2x, that's just 3x. So we have 3x minus x squared. So now we got to remember, we got to take the antiderivative, and then we'll plug in the 3 and the 0 and subtract. What's the antiderivative of 3x? 3x squared over 2. And then minus 1/3 x cubed. And we're going from 0 to 3. So we're going to plug in the 3. I don't need that much room for plugging in the 0, because that's going to be nice. But we do have to plug in the 3. So when we plug in the 3, we have 3 halves of 3 squared. Minus 1/3 of 3 cubed. When time's running out. Love this. Okay, so what is 3 halves times 9? 27 halves. Minus, what's 1/3 of 27? It's 9. Now we need a common denominator. How many halves? 18, so we get a final answer. 9 over 2. Time goes so quickly, don't you just hate it? So I did put a video. I think I have most of the answers for these on my, but you can always ask any of these that I didn't get to, because there were some doozies I didn't get to. If you don't understand it from the written explanation that I gave you in your notes, please ask me tomorrow or check the video online. And homework is the practice exam 1 to 28, the new one that's stapled. Practice exam. Oh yeah, go. Practice exam number 1.